So let's look now at writing and balancing chemical equations. Now, when we do start writing and balancing chemical equations, the equation or the chemical equation is used to describe a chemical reaction. So if we're trying to describe a reaction, we're going to use a chemical equation. Now we may want to describe that reaction as a word equation, using the actual chemical names or the words to describe the reaction. And if we're talking about a reaction, we may describe the reaction like this. If we combine hydrogen and oxygen, we're going to get water. And that would be just the description in words. And sometimes that is useful, but more often than not, we actually describe the equation using a formula equation, using the actual chemical formulas to describe the reaction. Now, if we were describing this same reaction of hydrogen and oxygen to water, we would just use the chemical formulas. So the chemical formula for hydrogen is H2, oxygen is O2, and together we get H2O. Hydrogen plus oxygen is water. Now, when we look at this formula equation, we have two sides of this equation. We have what we're starting with and then what we end up with. Now, we don't say start and end. How we describe this is reactants and products. What we start with are the reactants and what we end up with are the products. Now, a chemical equation that looks like this, where there's no numbers, is called a skeleton equation. So our skeleton equation refers to an equation where there's no numbers in front. And we're eventually going to work towards a situation where we put numbers here, but right now without numbers it's considered a skeleton equation. Now, before we can start writing and balancing chemical equations, we have to first do our conservation of mass. We have to show that atoms are conserved. And to do that, we have to do some counting. And so we have a technique to count all the atoms. And we're going to work our way through this technique really slow here to start. But let's imagine we had this situation. 5H2O. A number in front of H2O, hydrogen and oxygen, obviously we know that is water. Well, if we're trying to count these atoms, what we often want to think about is think of that H2O, and much like math, think of it as brackets around that. And now what we can start to do is we can see there's little pieces. The 2 on the H2O tells us there are 2 atoms of hydrogen. And the imaginary one, it's not written, but it's there, tells us there is 1 atom of oxygen. Now, if we have a number in front of the H2O, that tells us there's 5 molecules of hydrogen. And the coefficient tells us the number of molecules. So in this situation, we have 5 molecules of H2O, and the subscripts, these numbers down here, are actually going to come into play, but the subscripts, and they tell the number of atoms. Now, if we have the number of atoms and the number of molecules, then we can count the total number of atoms. And to count that total number of atoms, it's just some pretty easy multiplication. What we do to find the number of hydrogen is we have 2 hydrogen atoms per molecule and 5 atoms. So to find the hydrogen, it's just 5 times 2, which gives us a total of 10 hydrogen. Same thing would apply to the oxygen. There's 1 atom of oxygen in water and 5 molecules, so we would have to go 5 times 1, and if you can do these numbers in your head, even better, and we have a total of 5 oxygen. And that's how we count the number of atoms. And it's very important to count the number of atoms as we work our way through to determine the balanced equation. So let's try one more here. We have now formulas with brackets and subscripts, and there's a lot going on in these questions. So what we have to do is we have to remember we have 2 molecules. 2 molecules of this whole thing, Ca3PO4 2. So when we're doing our count, Calcium, the Ca, well, that's pretty easy because we just have 3 calcium times 2 molecules, so we have a total of 6 calcium. And that's just like we did before. Now, when we're looking at phosphorus, the P here, it's a little bit different. On this P, there's an imaginary 1 right here, and we have to concern ourselves with this 1 as well as this 2. So to start, we actually need to go 1 times 2. That'll tell us the number of phosphorus atoms, and then we have 2 molecules, so we need to times that by 2 again, and we'd have a total now of 4 phosphorus. Oxygen, same thing. We first have to take the 4 inside the brackets and multiply by this 2 to find the number of oxygen per molecule. So there's 4 oxygen times 2. Now that'll tell us the number of atoms per molecule, but remember, we have another 2 molecules here. So when we multiply that all together, 4 times 2 is 8 times 2 gives us a total of 16 oxygen. And counting techniques, very, very important as we get into the law of conservation of mass and writing and balancing chemical equations.